Yes, sir.
Yes, sir.
Yeah, fine. Unit 3. First, I'll simply brief what are there in Unit 3. Here. First one is superposition theorem. All the theorems, network theorems. First one, superposition. Second one, reciprocity. Third one, Millman's. Fourth one, Thevenin. And Norton. Okay, then last one is MPTS, maximum power transfer theorem. Okay, 1, 2, 3, 4, 5, 6. Total 6 theorems are there in Unit 3. Okay, depending upon the theorems, they are going to ask some numericals. So for that, we need to understand how we are going to, means basic behind all these theorems, we are going to understand first. Okay, now in the last topics, Unit 1 and Unit 2, we have seen the different methods of AC and DC circuit analysis. Fine, we know how to simplify the given networks. Now, these theorems, we are going to apply these theorems to those simplified, or I can say equivalent circuits. Okay, first today we are going to discuss regarding the superposition theorem. Fine. Now, superposition theorem. Okay. Superposition theorem states that it's, first of all, it's only applicable for linear and bilinear networks. Okay, what do you mean by linear network? Yes, anyone? What do you mean by linear network?
Sir, all the branches lie on the same plane.
No. Linear network is a network, okay, where the parameters are constant. In the sense, the parameters do not change with the current. Then what do you mean by bilateral? Bilateral network. The behavior of the circuit characteristics are same irrespective of the current direction through various elements. I can call it as a bilateral network. So this this superposition theorem is applicable for linear and bilateral networks. linear, constant parameters means the parameters of the circuit will not change whenever the change in the voltage and current in the circuit. Bilateral network, the circuit characteristics of irrespective of direction of the current, direction of the current through various elements. Okay, now here in any multi-source complex network consisting of a linear bilateral elements, okay, if my circuit consisting of more than one sources, that may be a voltage source or a current source, okay, the voltage across or a current through any given element of the network is equal to the sum of individual voltage or currents produced independently across or in that element by each source acting independently. It means if I am having two sources, that network is linear and bilateral elements, which consist of linear bilateral elements, where the sum of individual voltage source or currents produced independently by each source acting independently, when all the remaining sources are replaced by their respective internal impedances. Okay, if the circuit consists of, okay, dependent current and voltage source, then we are going to keep those dependent voltage source and current source as it is. Those sources should not be replaced by open and short circuit. But whenever the circuit consisting of independent voltage source and independent current source, we are going to replace this independent voltage source by short circuit, or if the internal resistance of independent voltage source is given in the sense, we are going to replace that with that resistance, internal resistance, and for independent current source we are going to replace this with circuit. Okay, now for clear explanation to understand this superposition theorem, we are going to solve one problem, then we'll get to know how we are going to apply this superposition theorem for linear bilateral network. Okay, first here you can see that this is the circuit. This is a circuit given. Okay, are there? Yes. How many sources are there?
Three.
Three sources. In that, two voltage source, one current source. Correct?
Yes, sir.
And three resistances. Here, this one is 6 ohm, 2 ohm, 3 ohm. This is 6 volt, 18 volt, and 2 ampere. Okay, they given this one as voltage V. Now we need to find voltage V, this voltage V across 3 ohm resistor using super for the circuit. Okay, now first step, select a single source acting alone, short the other voltage sources and open the current sources. If internal impedance are not known, if this voltage source, this voltage source, this current source, here in this circuit the internal resistance are not given. Okay, for this voltage source, this voltage source, this current source, internal resistances are not given. Fine. Now what you have to do? Select a single source. Replace all other voltage source by a short circuit and current source by a open circuit. Okay. Now I am going to select this 6 volt. See here, I am 6 volt plus minus. Okay. Then what I need to do with this voltage source, 18 volt source?
Short circuit.
Yeah, I need to short this one and current source
Open.
open circuit.
Open circuit.
Yeah. Here I am rewriting this one by selecting a single source 6 volt. I am going to short this voltage source here 6 volt. I opened this. Okay, I opened this. Now 6 volt, 2 ohm, 6 ohm, 3 ohm. Okay, we need to find the current V. Okay, next step, find the current through or the voltage across the required elements. These are the elements. Okay, we need to find voltage across or current through these elements. Due to the source under consideration, here I consider 6 volt. Due to this 6 volt, the current will flow. We need to find the current through or voltage across that resistance. Okay, then last, add all the individual effect by produced by individual sources to obtain the total current or voltage across the element. Here we need to find this voltage V across the 3 ohm resistor. Okay, now I selected this 6 volt resistor, so I short circuited this, I open circuited the current source. Now I need to find the voltage across 3 ohm or these elements. Now tell me how these 2 and 6 ohm look like, parallel or series?
Parallel.
These 6 ohm and 2 ohm are now I'm going to reduce my circuit as now tell me 6 in parallel to 2. Tell me the value. Yes.
1.5.
1.5.
1.5 ohm. 1.5 ohm. Okay, here 3 ohm resistance is a voltage V. Okay, this is okay. Now find the total current. Find the total current in the circuit. Now I am going to reduce this one to 6. 1.5 plus 3 is how much? Tell me total impedance of this network.
4.5.
4.5. 4.5 ohm. This is 6 volt plus minus. Tell me the current flowing here. I. I equals to how much? Yes.
3.3.
6 volt is there, 4.5 resistance is there. I equal to V by R.
1.33.
6.4
1.33, sir.
1.33.
1.33 ampere. The current flowing in this circuit due to this 6 volt is 1.33 ampere. Okay, now I need to find the voltage across 3 ohm resistance. How I am going to find? See here, the current flowing this resistance is the same current flowing here. Agree?
Yes, sir.
Yeah. Now voltage first due to 6 volt voltage source, voltage across 3 ohm. I am going to name it as V dash. Okay. See, for simplification, I am going to rewrite this plus minus. Okay. This is 1.5. This is 3. 1.5 ohm, 3 ohm, 6 volt. Due to 6 volt current I is flowing, we found out that current I is 1.3 ampere. Okay, now the voltage across 3 ohm resistors V dash is equals to 3 into
4 volts.
4 volts, 3 into I,
4 by
that is 3 into 1, sorry,
we can write it as 4 by 3, sir. It will be easy.
4 volt. Yes?
Sir, but
Yeah, tell me.
in figure 3, you take the current in reverse.
Where?
This should be in the positive to negative, sir.
Same only, na? This one you are talking, right?
Sir, yes, sir. In 6 volts, sir. From plus to
Current will flow from positive to negative side, right? Higher potential to lower
No,
side, lower potential.
you have shown it is flowing from negative to positive.
Yes. This one. Okay, I. Total is, now we got 4 volt reduced to 6 volt. The same we need to calculate with 18 volt as well as 2 ampere current source. Now V dash we got as 4 volt. Okay. Now consider 18 volt. It means I am going to short circuit. This is 6 volt. If I consider 18 volt plus minus 6 ohm. This one is open circuit. This one is short circuit. Okay. 2 ohm, 3 ohm, 6 ohm, 18 volt. Fine. Here this one is I. Okay.
So take it as I dash.
Which one?
No, because previous case also we took I. You can take I dash.
I can take it as I3. Okay.
Okay.
Current flowing in a 3 ohm resistor is I3. Why? Because this is total IT. The current flowing from this source is total current IT. It's going to divide in two currents. This current I am going to take as I 3 ohm. Okay, plus minus V. Now I can rearrange this circuit. Plus or minus 18 volts, 6 ohm. Okay, now see here, this 2 ohm and 3 ohm are in series or parallel.
Parallels.
How we are going to see in simple way, if current is dividing into two parts, then we can simply call it as the parallel circuit. The same current is flowing through the network elements or these resistance, then I can call it as a series circuit. Whenever by simply seeing, we can say that these two are parallel. Current dividing different current parallel. Now you can write 2 ohm, 3 ohm. Okay, these two are parallel. Yeah, tell me. 2 in parallel with 3.
1.2.
1.2. Okay, 1.2. This is 6 ohm. This is 1.2. Yes.
These
Now,
two are series and we'll replace them with single resistor.
okay. Total current is
2.5.
current is
18 by 17, 7.2.
yeah 18 by 7.2 is 2.5 ampere. Okay. Now applying current division rule. It means we need to find the voltage across the 3 ohm resistance. For that we need to calculate the current through 3 ohm resistance. Here need to find I3. Okay, for that this is 3 ohm, this is okay
2 ohm.
2 ohm. Now correct, this is 2.5 ohm.
Yes, sir.
Now current division rule, I3 is equals to total current into opposite resistance divided by total resistance, or
Three.
opposite impedance divided by total impedance of the circuit. So I3 is equals to total current is 2.5 into opposite resistance is 2.
1,
2 ohm.
1
Here
amp.
2.5, this is 2 plus 3, total I'll get 1 ampere. Now due
1
to
into
this 18
3.
volt resistance, the voltage across the 3 ohm resistance we need to calculate. Okay, that I'm going to call it as V double dash. When the 6 volt is acting alone, I named V dash. Here when I am going to calculate the voltage drop across 3 ohm resistance, when 18 volt is acting alone, I am going to name as it V double dash. That is I3 into 3 ohm, that is 1 ampere into 3, that is 3 volts. Now we need to calculate the voltage drop across 3 ohm resistance by considering only 2 ampere. We got by considering 6 volt as V dash equal to 4 volt, by considering 18 volt, that is V double dash equal to 3 ohm 3 volts. Then we need to calculate the voltage drop across 3 ohm resistance by considering only 2 ampere, that is if I am going to write, we need to replace the voltage source with short circuit. Okay, short circuit 6 18 volt source is a short circuit, then 2 ampere current source is acting alone, 2 ampere, 3 ohm, 2 ohm, 6 ohm. Okay, V triple dash, we need to find V triple dash, where this 2 ohm and 6 ohm are in parallel. 6 ohm in parallel to do, that is 1.5 is in again series with 3 ohm resistance. Series or parallel?
So there won't be any current across short circuit.
Yes, but first tell me that this 2 and 3 ohm are in series or parallel?
In series.
How series? These two are also parallel because current in dividing, right? Now we need to calculate this 6 and 2. See here, the circuit after taking these two are parallel, 1.5 will get 1.5, then 3 ohm, This is short circuit. See here. In between these two, a current source is there. These two are parallel. This is 2 ohm, this is 3 ohm, this is 2 ampere. Correct?
Yes, sir.
Yeah. Now we need to calculate this voltage across this plus minus V. I can simply write so 5. Okay, 1.5 ohm. This is nothing but 6 in parallel with 2, 3 ohm, plus minus V, 3 ohm. Current direction in 3 ohm resistance. See, current is flowing like this. Here, this I3 we need to find out. Okay, now I3 is equals to total current 2 ampere, opposite resistance 1.5 ohm divided by total resistance 3 plus 1.5. I'll get I3 as 0.666 ampere. Okay, now phi triple dash is equals to current I3 is flowing like this. Tell me, I need to take plus or minus. Minus 3 I3 is equals to minus 2 volt. I3 is 0.66 into 3 is 2. That is minus 2 volt. Okay. Now what superposition theorem states? Now we need to add all the individual effects produced by individual sources. The effect produced by considering only 6 volt is V dash, that is 4 volts. Effect considered by 18 volt is V double dash, that is 3 volt. Effect considering only the 2 ampere is V triple dash, that is minus 2 volt. Now the total V across the 3 ohm resistors will be V equals to V dash plus V double dash plus V triple dash. Total Karthik Kalmadi, mute yourself.
Yes, sir.
4 plus 3 minus 2. Total is 5 volts. The voltage across 3 ohm resistance is 5 volts. See here, the steps are simple. First, we need to consider any source acting alone, and we need to calculate the effect produced by that single acting source. Okay, then again we need to consider all the individual effects produced by all the sources. Then we need to add the effect of the sources. Here consider only 6 resistance. The voltage drop across 3 ohm resistance is 4 volt. If I am going to consider 18 volt only, then I'll get 3 volts across 3 ohm. If I am going to consider only 2 ampere, then I got voltage drop across 3 ohm is minus 2. So according to the superposition theorem, V dash plus V double dash plus V triple dash, 6 volt due to 6 volt due to 18 volt due to 2 ampere, that is 4 plus 3 minus 2, total is 5 volts. Okay, here see here one more simple one. Okay, minus plus 10 volt, 10 ohm, 40 volt, 5 ohm, 20 volt, 2 ohm. This is a circuit given. First tell me how many sources are there?
Three.
Total 3 sources
Three.
are there. All 3 are voltage source only. Yes. Okay. Now we need to consider any one of the voltage source. Okay. If I am going to consider 20 volt, here also internal resistance of the not given. So I am going to that voltage source by a, see here, 5 ohm. I am going to replace this 20 volt as a short circuit, then 2, 10, this, sorry, I am going to consider this 40 now. Okay, now here this is correct. Yes, tell me, whatever the circuit I have drawn here, it's correct or not? Yes. If I am going to consider only 40 volts, then
Short circuit 10 volts also.
Sir,
yeah, we
10
need to
volt.
short circuit this 10 volt. Whenever we are considering one voltage source, in the sense there other voltage sources must be short circuited. Okay, now here question, find the current through 2 ohm resistor. We need to find the current through this 2 ohm resistor. Now tell me, this 2 and 10 are in series or parallel?
Parallels.
Parallel. 2 is in parallel with 10. How much? Yes, 1.66. 1.66 ohm. Okay. Current due to this volt 40 volt is flowing like this. Okay. Now total current and call it as I. Current I is divided by 5 plus 1.66. How much?
6
I'll get
amperes.
6 ampere. I'll get 6 ampere. By current division rule, if my current is here I, okay, you need to find this current I dash. Total current we got as a 6 ampere. Now I dash I am going to calculate as 6 into
10, sir. 6 into 10 by 10 plus 12.
why 10?
It is the other opposite, this one in the combination.
Yes, here the opposite combination is 10 ohm. 10 divided by total resistance 10 plus 2. I dash is equals to 5 ampere
5 amp.
due to this 40 volt. Okay, now same we need to calculate by considering 20 volt. Then this 40 volt and 10 volt will be short circuited. Then we are going to consider only 10 volt. Then this 20 volt and 40 volt will be short circuited. If I am going to consider this 20 volt, I will get I dash equals to minus 2.5 ampere. 5 minus, because due to this minus here positive here, current will flow like this. If I consider 10, this is I double dash. If I consider 10 volt, I triple dash, I will get 1.88 ampere. Here total current I equal to I dash plus I double dash plus I triple dash. By superposition theorem, I am going to add all this 5 minus 2.5 plus 1.88. Total current will be 38. Okay, I didn't solve for 20 and 10 volt here. Okay, because it's a simple one. Whatever the procedure we have seen in the previous example, it's the same. And here time also got over for this period. Okay, next class we'll see the superposition theorem with dependent sources. Okay, now
Yes, sir.
I'll download.